What does an impeller do, and why should we replace it? Hi, I'm Sailor Eric, and if you're interested in boat maintenance or sailing adventures, you've come to the right channel. As I endeavor to do my own boat maintenance, I learn and then subsequently share what I've learned so that you too might benefit. I think all sailors should know the ins and outs of their respective boats, and nothing is a better teacher than to do the work yourself. The impeller is this rubber wheel. It has multiple vanes protruding out of it. A raw water pump will spin the impeller over a flat edge called a cam to compress the vanes on that plane just ahead of the inlet. The compacting vanes create pressure while the impeller is spinning across the cam. But as the vanes come off of that plane, they flip back to their original state, and that causes a vacuum or a suction created over the inlet. The vacuum draws the raw seawater from the inlet hose. The water is then transported through the chamber in the direction the impeller is spinning to the outlet hose, which leads to the heat exchange to cool the engine. This small rubber device is spun at high speed. Think thousands of rotations per minute. If these vanes eventually wear with cracks or ultimately break or disintegrate, the debris has to go somewhere. The debris works itself into the engine via the heat exchanger, and that in itself could cause water blockage. And because the integrity of the vanes are compromised, a lack of water draw can occur from what's left, and that can cause overheating of the engine. Getting the pieces of rubber debris out of the heat exchange or the remainder of the engine is labor-intensive work, and it's an expensive repair for a mechanic. It'll cost a bundle, think $1,000. The cost of an impeller can be around $35. So the idea is to replace these things about once a year, right? And it's just worth it from the standpoint of risk-reward. It's good insurance. First, we must obtain the replacement impeller. To obtain a new replacement part, I went to Amazon.com and searched based upon the engine the impeller is for. The replacement impeller is not the same manufacturer or part number as the original, or even the last impeller that is currently being replaced. It is easy to get lost in part numbers and manufacturers, but in today's global supply chain, you must roll with the idea that newer and better manufacturers have come along for the same part. Look for compatible parts that carry the physical properties and specifications as the part you are currently replacing. Next, we must find and access the impeller housing. You can recognize the impeller pump and housing as it has a flat face covering a compartment that is attached to two hoses. My pump is unfortunately in an inconvenient place and is essentially on the opposite or aft side of this engine from my access point here in the companionway. I have to go over the top of the engine and hang upside down to do my work, which is not great for filming YouTube videos. Before proceeding, if you are doing this in water, close the through-hole valve for the water inlet and avoid the possibility of being doused with water when opening that housing. Remove the plate with a socket wrench. I left my socket wrench at home, but did have a drill bit that had the required socket size for the hex nuts, so I put the bit in some vice grips and then worked loose the bolts. Pull the impeller straight out. Note that the impeller housing is usually made of bronze, which is a soft material. So be careful if prying out the impeller to avoid damaging the housing case. Better yet, use a tool that can grab the impeller properly and pull it out laterally. Avoid using pliers on the fins to pull the impeller, as the fins can tear. Tools that can be used to pull the impeller out could be 2 pairs of pliers, preferably needle nose, to pull the impeller evenly out, a pair of channel locks, which would pull out the impeller, 2 blunt rods that you would pry out the impeller with, You could do the same with screwdrivers, flathead screwdrivers, but this would not be recommended because these flatheads could damage the impeller. Or a specialized impeller puller tool, which you could buy on Amazon for about $40. I used these two punch tools, which are like metal rods to pry them out because they're very blunt, being careful not to cause any stress on the brass construction of the housing while doing so. If you have experience pulling out an impeller, share in the comments the tool or method you've used with the most success. Once the old part is out, compare it with the new impeller to make sure the part you're replacing is compatible with the one you're replacing it with. Also, check the plate and determine if there's any damage, residue, or scoring. You should strongly consider replacing a damaged cover plate. Deep gouges or imperfections in the metal can result in decreased pump performance and a higher likelihood of failure. In the event of any residue or scoring on the inside of the plate, use a scrub pad to remove it. Leaving any residue or scoring in place can result in degraded pump performance and decreased life of the new impeller. Prior to installing the new impeller, you should add some lubricant, silicone-based, or something that does not risk degrading the rubber material. Oil-based lubricants such as WD-40 have potential to damage the impeller over time because it's not compatible with the rubber. But the oil lubricant generally does not last long. Water washes it out of the housing. So this is not likely to be a danger over the long term. The idea here is to prevent the impeller from running dry, and adding some lubricant as part of the install helps prevent that. My suggestion is to go with a silicone-based lubricant. You can imagine that a dry or unlubricated rubber object spinning at thousands of rotations per minute could disintegrate rather quickly. So it's worth some preventative attention. Generally, water is drawn into the housing rather quickly, and once water is drawn into the chamber, that will act as the lubricant. Most replacement impeller kits will often also include a new O-ring. The O-ring fits around the impeller housing and acts to help seal the water inside the casing, which keeps the water pump efficient. Replace this if you have a new one. Insert the new lubricated impeller. If you are having trouble manipulating the fins as you are inserting the impeller, a trick is to compress the fins preemptively by contracting a zip tie around the impeller. As you slip the impeller into the housing, you would be pushing the impeller through and out of the zip tie. Next, replace the plate and screws. Tighten the screws firmly and evenly with the appropriate tool. Full disclosure, it took me 3 attempts to ultimately get everything right. On the first occasion, the impeller was not coming out or even moving, and I did not want to force the situation without doing some research in case I was missing something. On the second occasion, I had better tools to include blunt-ended punch tools, which I ultimately used to pry out the impeller, placing even pressure on opposite sides of the impeller body. However, I did forget to lubricate the new impeller before installing it. I also forgot to replace the O-ring and had to go back, remove the plate, and replace that O-ring. This is my third go around today, where I pulled out the recently installed impeller, lubricated it, and used the zip tie method to reinstall that impeller. I feel pretty good that I've got everything right at this point. When doing things yourself, especially when it's something you only do occasionally, it is very likely that what would take a professional 15 minutes is going to take you a few hours. Don't get discouraged. The experience and understanding you gain by doing it yourself is worth the efforts. This is one more piece of the system that you have greater awareness of. And even if it is a few years before you have occasion to do it again, you will find that the foundation was formed from the last time that you performed the action, and the depth of your understanding grows on that foundation. If you really want to learn something well, force yourself to explain it to others. I would recommend Marine Diesel Basics, this book by Dennison Berwick, as a handy at-home or on-boat resource. I find it useful. It's great for helping understand the basics of diesel engines. If you stayed until the end of this video, if you're not already subscribed, please consider subscribing to this channel. Subscribing is free to you and moves me toward the possibility of receiving advertising revenue down the road. This would help support my sailing habit. It would be a great way for you to say thank you for the information. For my current subscribers, thank you for your support, and you can also certainly help by pressing that like button. Thanks for watching. Don't forget the lube.